Hello everyone, we are Group 6B, and today we are going to present about our report and finding on our experiment to research about the relationship of the distance between the electron in the electrolytic cells and the total mass deposited on the electroplated metal. As we all know, electroplating is a process of plating one metal onto another using either electrolysis or hydrolysis. This process is commonly used to prevent the corrosion of a metal or purely just for cosmetic reasons. It involves by passing an electric current through a solution called the electrolyte. This is done by dipping two terminals called the electrode into the electrolyte and connecting them into a circuit using either a power supply or a battery. As for anode, which is the positive terminal, oxidation reaction will occur. And for the negative terminal, which is cathode, reduction reaction will occur. Since both of the reactions occur simultaneously, we call it a redox reaction. Faraday's first law states that the amount of substance produced at an electrode is directly proportional to the quantity of electricity that passes through the electrolyte, while Faraday's second law states that the amount of different substance produced by the same amount of electricity is inversely proportional to the change of ions. Faraday's first law is important in our research because as the distance between electrodes increases, the internal resistance of the electrolytic cell also increases, causing the total current in the electrolytic cell to decrease. As the current decreases, the amount of substance produced will also decrease due to the decrease in the quantity of electricity that passes through the electrolyte. Now, moving on to methodology.
First thing first, to success our experiment in electroplating, we use nails for a cathode and copper for anode. So, our procedure first, we need to sand with sandpaper our nails and copper to remove any build-up oil or dust on the surface of nails and copper. Second, we need to set up our apparatus in a figure that we could show up, and then we need to mesh of each nail individually, and the value we need to tabulate it into the data. Okay, and then the distance between cathode and anode we need to set as 2 centimeter, and the power supply we need to turn on for 10 minutes. The power supply is turned off after 10 minutes, and the nails and copper rod are taken out from the electrolytic cells. And then the nails, after the experiment, after the power supply is turned off, we need to weight our nails and the value we tabulated into the data. And then we just repeat our step for 4 different nails. So the mass deposited on the nail we need to calculate, and then we need to plot our graph about mass deposited again distance between the electrode. So that's all. Thank you.
So this is the result for our experiment. We have measured the distance between electrode in electrolyte cell from 2, 4, 6, 8 and 10 centimeter, and there's our mass deposited for each nail. So how do we get this mass deposited? So basically we just subtract the mass after and the mass before the nails have been in the electrolytic cell. So moving on with the graph. So this is the graph distance between the electrolyte in the electrolytic cell against total mass deposited. As you can see from the graph, the distance from 2 to 4 centimeter, the mass deposited has been decreased significantly, but from 4 to 10, it still decreases, but there's no drastic changes as in 2 to 4 centimeter. This is because at 4 centimeter, the nail has reached its maximum boundaries, so it wouldn't receive as much as copper particle like 2 centimeters electrolyte.
Now, let's move to observation and discussion.
Observe that the green with light blue precipitates are released from the copper anode and take different times to reach the iron nail, which is scattered in the process of electroplating by changing distance between electrodes. The colorless salt water also changed to brownish yellow with different intensity when conducting the experiment. After 10 minutes, the electroplating finished and the quantity of the copper on the iron nails or the mass deposited are measured and are different for the different distance between electrodes. The greater the distance between the electrodes, the smaller the mass deposited. This is due to the resistance in the electrolytic cell increasing and the current decreasing as potential difference increases when increasing the distance between the electrodes according to Ohm's law. The decrease in current will cause the reaction to become slower because the amount of electrical charges transferred within the electrolytic cell become lesser according to Faraday's first law. Therefore, the rate of electroplating of copper on iron nail decreases. Hence, cathode becomes harder to electroplate when the distance between cathode and anode increases. Now we move to the conclusion part.
In conclusion, the objective of the experiment is successfully achieved. Based on the result obtained, the usage of Faraday's first law in electroplating is accepted, in which the internal resistance of the electrolytic cells increase as the distance between the electrode increase. This results in a decrease of current in the electrolytic cell. Since Faraday's first law stated that the amount of substance produced at an electrode is directly proportional to the quantity of electricity that passes through the electrolyte, the decrease in current in the electrolytic cell will cause the quantity of electricity that passes through the electrolyte to decrease, which causes the amount of substance produced at the electrode to decrease. Thus, as the distance between the electrodes increase, the total mass deposit will decrease, since the total rate of electroplating decrease as the distance of electrode increase. Thank you.
Gambar aku. Okey, sekarang dah nampak larut sikit, dah larut, dah makin larut. Nak rasa, jangan try rasa, bahaya. Kalau duk makmal, jangan mencuba-cuba merasa-rasa. Dah letak garam, rasa dia masin je, sama je. Lambat dah.
Memang.
Cuma dia boleh dekat tapi jangan terlalu, jangan sampai bersentuhan.
Di mana kita dapat kupung ni?
From ni, grup sebelah sana.
Orang balak.
Diorang ada banyak, aku tahu. Aku mula nak ni, potong aluminium, potong tin tu. Potong ni. Cepat sikit.
Berapa minit?
Baru 2 minit. So kalau kita tengok kat sini sekarang, okey. Kita nampak macam ada satu mendakan yang jatuh.
Mendakan apa tu?
Aku dah lupa nak kata dia apa.
Nanti temperature ni
Kita tengok ada something perkara yang jatuh-jatuh kat situ. Kalau nak tahu benda apa yang jatuh, kan, kena tunggu lagi video next. Nanti kita orang terangkan sebab apa.
Sekarang ni kita orang tengah buat je.
Sekarang kita tengah fokus. Jadi kita tak boleh nak terangkan.
Betul.
Di sini sebenarnya kita telah telah bermula proses penyaduran logam. Memang dah lama. Tapi tu lah kena tengok.
Balik terus ni. Aku tunggu lah. Aku ada dalam tu, aku ada. Yang kita ni boleh saya tahu, saya tahu.这个最后第二个，有点的，蓝就年轻人。收点慢。我的巴斯大概差不多1点了。
Lapan, tujuh, enam, lima, empat, tiga, dua, satu. Wow.
Pegang.
Pegang ni. Yes.